is still in our same unit, but now we're going to switch gears from talking about kinetics to talking about a new measurement or new unit of study called equilibrium. Have you heard the word equilibrium before? What does it mean to you, that word, when you hear it, equilibrium? Like walking and like not falling over, right?
I said equality.
Oh, equality. Oh, yes, equality. That's a good one. I'm sorry, Duco, I totally misheard you. I'm so sorry. Please forgive me. In chemistry, though, it is the study of the extent of a reaction. You're right about the equality thing. We'll get to that in a moment. Equilibrium is the study of the extent of a reaction. So not every reaction, when you put the reactants together, reactions will stop over time. Not every reaction will use up all of its reactants and make products. And so equilibrium helps us to know whether or not we have a reaction that will produce a lot of products or just won't. Because some reactions are just, they're not meant to work out. Kind of like relationships are not always meant to work out, and that's okay. It just is the nature of things. Is that his water bottle that's making that sound? That's so weird. Okay.
Got it.
Thank you, Elliot. Okay, so we need to learn how to write what's called the equilibrium constant. This is a really important concept. And so many of you friends are signed up already to take AP Chem. If you are, you got to lock in. The equilibrium constant, do you remember when we were talking about rates last time and we had to write the word rate out every time? We don't have to do that for the equilibrium constant. It has an abbreviation. It's capital K and then with a subscript EQ to stand for equilibrium constant. So big K is our abbreviation. The equilibrium constant, writing this is what I like to think as fun and easy because once you can figure it out, all of them are the same. Okay, so here again is my pretend chemical equation. The small letters are the stoichiometric coefficients. That's important. The equilibrium constant looks a little bit like that rate law that we talked about last time, but it's not. So we have to make sure that we keep them separate in our mind. In order to calculate K, you will always, K is always the concentration of products divided by the concentration of reactants. And we'll talk about what this numerical value means in just a moment. Okay, so for this generic chemical equation, KQ can be written the same way for every single equation by doing this. Oh, I don't know why I did D first. I don't normally do that. I've been a bit of a dummy today, so if my teaching is not great, I apologize. It must be the roids. Not them, not those kind of roids. Sorry, Joe.
What is it?
It's just prednisone. Have you guys ever had to be on prednisone for anything? It makes you feel so weird. It's a stimulant, and so you're perpetually awake. But also, like, it makes all of your processes just run so much faster. So, like, you get hot. Like, my face feels so hot. And, like, my heart rate yesterday, my watch thought I was exercising for 360 minutes. That's 6 hours. I was sitting on my butt grading paper, like, doing homework. And so it just makes you want to do all the things, which is crazy, but also, like, I just feel, like, super shaky. But yeah, so if my brain power is not great, I'm blaming it on the weight. Okay, so this is what you'll need to do for all of the times when you have to, if you have to calculate K, you'll have to put, write a K, and this is how you write the equilibrium constant. Let's just spend a little bit of time talking about what K means. So what does the value of KEQ mean, or tell us? There are two things that can be true. Either K is greater than 1, or K is less than 1. If K is greater than 1, let's look at this math here. In order for K to be greater than 1, your numerator must be bigger than your denominator, right? That's just simple math. And so if K is bigger than 1, it means that you have used up a lot of your reactants and made products. So we would call this a product-favored reaction. It means that the reaction wants to go in the forward direction, the way that it's written. There are some reactions where K is an extraordinarily large number. Like, I don't know it off the top of my head, but do you remember the story that I told you guys about my dad putting the sodium metal in the toilet? The reaction of sodium metal with water goes to completion, which means that almost every single reactant is used up to make a product, which makes it an excellent weapon because it leaves no trace, because it's completely used up. So what does that mean? If this number is almost 0, K will be a very large number. And so I think that reaction is like the K value for solid sodium and water is like 1 times 10 to the 40. So like really a big number. And so, excuse me, use that example to help yourself remember that the sodium was used up. They didn't find any remnants when they sorted through all of the porcelain and all of the, shrapnel, I guess, of his little explosion. And so what that means is that if K is very large, mostly all of your reactants are converted into products. The opposite is also true. If K is less than 1, it means that you have a reactant-favored reaction. Oops. And so what does that tell you? It means that you still have a lot of reactants left over after they've stopped reacting. Well, why would that be true? It just means that you have a chemical reaction that doesn't progress, or two things that don't really react together. An excellent example maybe would be of like two people who don't get along, like ever, like maybe Caden and maybe Sienna, maybe Joe and Sienna, maybe just Sienna. Oh, sweet Sienna. And so when you've got people that just don't get along, they try to avoid each other, right? It's the same thing for chemical reactions that don't want to progress. An example of this would be the reaction of gold with oxygen to form gold oxide. If you wear gold jewelry, you know that gold doesn't tarnish. This is a reaction that doesn't progress. And so the K value for this is something like 1 times 10 to the minus 60. So an incredibly small number because you have so many reactants left over and almost 0 products. And so if you have 0 divided by any number, that's just almost 0. And so that's why you would have a reaction like that. It just means that the chemicals don't react. And that's okay, that's just how they are. Let's see, what else do we have? examples from our homework to see how we can do on this. The first page of your homework is just writing KEQ. And then pages 2 and 3 are, can you hand one back to Megan, please, Hugo? Page 2 and 3 are doing some math. I'm going to leave one here for you.
I guess he's really not getting dunked anymore. Where was this?
Okay, let's do an example. Let's do number 1. If I write it here, will you guys be able to see it? If I write it here. You could just put that on the table there, or in the trash, that's fine too. Thanks, Emily. Okay, so let's do number 1A. Gents, to write the KEQ, all you're going to do to start out is write KEQ equals. And now your products go on the top. Your products are, there's only one product. And so we will write NCl3. You do not need to include the state of matter. So notice how I didn't write little g in parentheses. You don't need to write that. But then you do need to do something with the 2. That's your exponent. Remember when we were writing the rate law and I told you that the exponent was not the stoichiometric coefficient? That's still true for the rate law. But this is not the rate law. This is something else. Okay, so then the reactants go on the bottom, and there are 2 of them, N2, and it has a stoichiometric coefficient of 1, but we don't write the 1, so just N2. And then Cl2, and its exponent should be 3. That's it. I know, it's fun and easy. Okay, but there's a catch. And it's actually a happy thing. Only gases and aqueous solutions appear in the KEQ. No solids or liquids. The reason for that is because solids and liquids that are pure don't have it have a concentration of infinity because they're not diluted. And so we don't want to use infinity as a number in our math, so we don't include them. But now we're okay for part A because these were all gases. Let's do another one that has all gases. Let's do B. If I write this here, will you be able to see it? I know my computer is kind of in the way. For B, you'll write again KEQ equals, and now what should go on the top of this fraction? HI. Oops. It's square brackets, friends, not parentheses. That was for me. And then 2 is your exponent. And then on the bottom we have H2 and I2. Notice how I didn't write 2HI here. I wrote HI to the second power. How was that? Good? Okay, let's skip to G, yes. Okay, so when you get to these, you should look at them and say, oh, which one of these things do I not need to include? The first substance is a solid, so it can't be in KEQ. The second substance is also a solid, so that means it can't be in KEQ either. So what's left then? Well, just those 2 products. So it'll just be H2O to the 1, but we don't write that, times CO2 also to the 1, which we do not write.
Is that all you write?
That is all you write. Because, so like there's no even denominator because I crossed off all of my reactants. So they disappear. Okay, but now let's take a look at I. What happens when you have, I'm going to actually write this one out because it's a little confusing. So look at I and decide which things you'll like non-include in KEQ. You can't include solid or liquid. So this one doesn't appear and this one doesn't appear either. So that means you have to have products on top and reactants on the bottom. Your reactant, O2, appears in KEQ. That one stays. But then what do you do with the numerator? You don't have any products that can go up there. So what should we do? We can't not have it because something divided by O2 is not the same thing as O2. So when you have no product, just put a 1 as your numerator. When you have no reactant, you could also do the same thing. You could put it over 1, but why hassle yourself? Why do more work when you don't need it? So that's why I didn't put the over 1 there. So page 1 should be something that's pretty easy for you to manage. Let's now look at pages 2 and 3. Please skip page 4. We'll learn that on Thursday. We'll do a lab next week. I just don't know which day yet. So for pages 2 and 3, you're going to do the same thing that you did here, but now there's one extra step. You have to put numbers in and do the calculations. And then use what we learned about here to figure out what kind of reaction we have. Do we have a product favored or reactant favored? Okay, so let's look at number 2. You're going to need to write a KEQ, so you start on that while I'm erasing this.
Should we write out the letters first, or do we need that or not?
Yes, you do. You need the letters first. So for all of these, even though it doesn't say that you should write KEQ, you should write KEQ. There's no other way to get around it. Okay, so your KEQ should look like this. Remember, products over reactants. And now you can decide how you want to tackle this next bit. You can make yourself a data table, although I don't think that is really necessary. But you do just have to really be careful about where you're putting the numbers in. Okay, so KEQ then equals, what does the problem tell you as the value for CH2O? It says that is 0.441 M. Do you see that? So that goes here. M is your unit of concentration, it's molarity. That's the unit that we will always use to measure concentration for calculating K. And then H2 is next. H2 is 0.0331. And then the methanol, the CH3OH, is 0.00215. Now, the nice thing about K, so it's annoying to put these numbers into your calculator, will be annoying. But it's just tedious, there's nothing hard about it. But the nice thing about KQ is that it is unitless, so you don't need to worry about writing a unit. K doesn't have one. Okay, so let's do this math really quickly. The number that I got was 6.78, but then I'm going to round up to the 9. You should worry about significant figures. So just go back into your problem. There's 3 here, and 3 here, 3 in the answer. Can anybody else confirm the 6.79? Okay, so now what does that mean? It says, what does the value of KEQ indicate about the reaction? Is it greater than 1? So it's product favored. If it's less than 1, it's reactant favored. And that's all you have to write. Does this make sense?
Yep.
Okay, let's do a couple more examples and then I'm going to let you be on your own.
Second word, product.
Product favored, I'm sorry.
Huh?
Okay, look ahead. Are there any that you want me to do for you? Any that seem harder to you at first glance than others? 3? Okay. Are there any things in this reaction that we can leave out of the KEQ? Nope, they're all gases. Okay, so start by writing your KEQ. Products on top. But now our coefficient is not 1 for the NH3, so we need to put a 2 here. Does this make sense how I got this? Products over reactants. Okay, now you just have to do a little bit of reading and sleuthing and put your numbers in. You do have to do, like, write this part out on your paper. If you don't, I won't be able to give you any points at all if you get the math wrong. And the odds that you get the math wrong on this, guys, is pretty high. N2's concentration is 4.9 times 10 to the minus 4. I will remind you of how to put that into your calculator here in a moment. But then the H2 is cubed. I would say that when I'm doing these problems and I make mistakes, it's because I wrote the 3 here, but then I didn't copy it back down to here. So it's good for you to, like, lock into the details when you're doing these problems. It's pretty mindless. So it would be really easy for you to sit and watch Dance Moms and do all these problems. But if you're not going to pay attention, you'll get them wrong. So just background noise is okay, but lock in. Okay, so I promise I'd show you how to type this into your calculator again. Whenever you're doing times 10 to anything, you do not use second log. I'm going to repeat that again. Do not use second log. It means something different to your calculator than what you think it means. So don't get in the habit of being a good scientist and a good mathematician with your calculator. It doesn't serve you a purpose to have them and pay $150 for them if you don't know how to use them. Okay, so to do times 10 to the thing, you're going to press the second key and the comma, which is right above the 7 button. And when you do that, you don't need to use separate parentheses. So what you should do is type in 0.34 squared. And then you should, so I'm just going to write this here squared. Whenever you're pressing the divide key and you have more than one number, you need an extra parentheses right after you press this. So get into the habit of pressing divide and then parenthesis.
Do you put that in first or second column?
No, don't put this in. This is just how you do times 10 to the thing. So type in 0.34 squared, press divide, press parenthesis, and then you're going to do 4.9 second, comma, negative 4. And now that's 4.9 times 10 to the minus 4. That doesn't need its own parentheses. So you can keep typing times 2.1. Actually, I don't think you need it, but I would put it anyways. Maybe that parentheses there. Just hit your over arrow. Second again, comma again, -3, and then you can do the caret 3. You don't need to close any of those parentheses. It's not like Google Sheets. If you don't close them, it's not the end of the world. So, if you do this properly, you should get Now I want all of you to try this to make sure that you're knowing what you're doing. I got for my answer 2.55 times 10 to the 10. What? Did you not get that?
We need 3.
Actually you need 2. Thank you.
I got 5,500.
Can anybody else confirm my number?
Yeah, I got that.
I got 7 point.
Okay, let me see what you put.
I'm just going to do it one more time. Okay, I did it all separately and I still got the same. Somebody else got that too?
You need E to the third.
What did he forget, Elliot?
He did like, we did this in Greek. It's like the number, it's like E.
Yeah.
E to the third, not
Oh, it's not E. No, I just showed you how to do it.
No, I did that instead of the carrot.
Oh,
So I
got
did
it.
before the
Got
carrot.
it. Okay, I was going to say, because if you're trying to do E to the thing instead of this, I was going to get so mad.
I knew how to do that.
Okay,
I
good.
did
Okay,
the
good.
E to
Okay,
the third instead of pressing the
Sorry, I almost got. Okay, so what does this mean about your reaction?
product favored.
Product favored. That's quite a bit more than 1. Okay, turn to page 3, please. Look at number 7. Oh shoot, I forgot to fix my typo. See number 7, how it says there's a solid there, that's your reactant is a solid. Like, maybe X it out, because that will not appear in KEQ. I do give you a value of it, but it should not appear in KEQ.
What should we do?
Number 7, the first substance in the reaction, the NH4,2CO3, that's a solid. So just put an X through that because you don't want to write that in this equation. But then do you see where it says the NH3? Instead of typing open parentheses, I'd put a capital I there on accident. Do you see that? It's supposed to be a parentheses. My bad. Sorry about that. On number 7. It's the second substance, NH3. In the chemical reaction, it says NH3 IG. I just was a typo. My bad. And then, like, look at number 8 and 9. Do you see all the solids? Those don't appear in KEQ. So maybe make a note of that to yourself now, because you'll get a wrong answer if you don't.
Wait, what?
In numbers 8 and 9, do you see the solids?
Oh, the reaction and reactant.
Yep. If they're solids or liquids, they don't appear in KEQ, so you can't put the numbers are irrelevant. Okay, I think that's probably all you need to know for this. You have the rest of the time as your own to work on it. If you need help or if you want me to do a problem for you, I'd be happy to do that. Or just let me know what questions you got.